we're going to use 2 points to calculate the force vector. And in order to do that, we're going to have to calculate the unit vector of that geometry. So the first part, like I said, calculate the unit vector using 2 points. We're going to identify the point for which we need to calculate that unit vector, subtract the points from each other, subtract those coordinates to calculate the displacement vector. We're going to find the magnitude of the displacement vector. In that case, again, we're going to use the square root of the sum of the squares. And then we're going to normalize. We're going to divide our displacement by our magnitude. That means we're going to divide the vector that we got in step 2 by the magnitude that we got in step 3. Remember that unit vectors need to have a magnitude of 1. So this normalization is where this dividing by the magnitude, that's how we make it a unit vector. So let's say we need to find the force of tension using problem geometry. Calculate a unit vector that connects point A at 0x, 5y, and negative 3z with point B at 1x, negative 2y, and 4z. First step is to identify the points that we need to calculate our unit vector for. Sometimes we'll have to figure this out using our problem geometry. So if we have a spatial diagram, we'll have to figure out the coordinates of each point and then subtract them. But in this case, we were given our points in our problem statement. Step 2 is to calculate the displacement, calculate the difference vector of the 2 points. So that's where we subtract point A from point B or point B from point A. So in this case, our displacement vector, it's going to be point A x value minus point B's x value, which is 0 minus 1, so negative 1 in the I direction. AY minus BY in the Y direction. That's going to be 5 minus negative 2, or 5 plus 2 in the J direction. And then we're going to add AZ minus BZ in the K direction. That's going to be negative 3 minus 4 in the K direction, giving us negative 7 in the K direction. The next step is to calculate the magnitude of the displacement vector. So we're going to do the square root of the sum of the squares. That'll be the square root of negative 1 squared plus 7 squared plus negative 7 squared, giving us 3 times the square root of 11. We're going to normalize our displacement vector to get our unit vector by dividing our displacement vector by our magnitude. You're going to have to distribute out that division. You're going to end up seeing that in each term. We end up having a unit vector of negative 1 over 3 times the square root of 11 in the I direction, and so on. Part 2, if we're trying to find the force or the tension using this unit vector, most likely we're going to be given a magnitude of a force. So we're going to use our force magnitude and the unit vector to find the force vector. Now that we've normalized this displacement vector to give us only directional information, if we multiply it by a magnitude, it'll give us a force separated into its x, y, and z components in our vector format, making it easy to work with in a lot of situations. So just like our unit vector is our vector divided by its magnitude, we can use the same thing. The unit vector is going to equal the force divided by its magnitude, because we know that the force and the cable go in the same direction. We can rewrite that equation to be that the force vector is equal to the force magnitude times the unit vector. If we know the magnitude of the force in this cable is 50 units, then we can redistribute that 50 units out into each of those terms, again, to get our final answer for the force vector.